So good evening everyone. Am I audible to you?
Yes, ma'am, you're audible. Good evening.
Good evening. So today first of all we'll give some basic layouts of that about some nomenclature about the aerospace vehicle, and then we'll move to the core part of aerodynamics, and then we'll move to the core part of the propulsion. Before starting of that, today we'll clear up some basic part of this aerospace vehicle. So can you see my screen? First screen. Kindly unmute and say, okay?
Yes.
Right. Okay.
Yes, ma'am.
Right. So first of all, we'll come to this aerospace vehicle. Now, how can we classify this aerospace vehicle? Now, as I've said, what are the important factors that we will discuss over here? We'll discuss about the applications, the pattern of questions that can come from this particular topic, then how you can connect this type of questions with the other subcategory. Okay. Now, any aerospace vehicle, or I can say the classification of this aerospace vehicle can be basically classified in two ways. One is inside the atmosphere, another is outside the atmosphere. Now I hope it is quite easy for you to identify what does it mean by inside the atmosphere and what does I mean when it comes to outside the atmosphere. Okay. Now before going into more about the inside and outside, so what is atmosphere? Now it is a thin layer, so thin layer of air, and which is combined with different kind of compositions. Now here you have to understand what do I understand by the compositions. So this is very important to note down this how much percentage of nitrogen, oxygen, argon, carbon dioxide and other. Now why it is very important? Now let's take an example. To make any kind of combustion, so let's take an example of this way, that there are two type of propulsive system we have. One in the inside the atmosphere, like we can say air breathing engine, and if we have to go outside the atmosphere, we have something like a rocket engines, like chemical propellant, we have electrical propellant, right? Do you agree with my point? Please,
Yes.
you can unmute whenever I'm asking some question. You can unmute and answer, right? So we can classify the type of propulsive system in two ways. One is air breathing, another is a non-air breathing. So why we choose two different propulsive system? Because in outside atmosphere we don't have any kind of oxygen. So what that oxygen does, it helps to create a combustion. So for creating a combustion, so once the combustion process will held, then only it will initiate to create a propulsive system, then only the aircraft will move forward, right?
Yes,
So
ma'am.
for that we should know what is the composition of the atmosphere, and this compositions play a very vital role while selecting any or we can classify the different type of vehicle. Now next important part is what this percentage, whether it's by volume or it's by density. So what is this percentage? Now this is very important to understand. This is 78. Now some textbook you will find it is written as 79. So it varies from 78 to 79%. Okay, so that you can take it as a granted. So this 78 to 79% is the proportion by volume. Now this is a point that majority of the students get wrong. They know that some percentage. In the gate they will ask you by volume, by density, by mass and all of the above. So this is a very key point to remember. So this composition of nitrogen is 78 to 79, oxygen is near about 21, argon, then carbon, then remaining other gases. Now
Yes,
coming
ma'am.
right. Now coming to the layers of atmospheric composition, this is another very important. Now we know there are different layers, like starting from just a second. Where is the slide? Just give me a second.
Excuse me, this flight mechanics,
Sorry.
ma'am. This flight mechanics, na?
Yes, this topic is a part of flight mechanics. Okay, but for today we will give a basic of flight mechanics, and then we'll skip to aerodynamics and propulsion, because here some very important facts to say. So if you have that concept clear, so then only it will be easy for you to understand the aerodynamics and the propulsion. Okay, so this is a basic part that we will cover up today. Okay, and we'll discuss some of the important facts of this. What type of question is going to come in this from this particular topic. So
Yes, ma'am.
I think by mistake my slide got stopped shared. I hope you can see it right now. Can you see my slide?
Yes.
Yes, ma'am. Exosphere, thermosphere, mesosphere,
Yeah.
stratosphere, troposphere.
Very good. So these are the basic layers we know. But among this layer, again we have some subdivisions of this layer. So what is a subdivision? We have homosphere, which ranges from troposphere to mesosphere. Then another layer we have is a heterosphere. Okay, heterosphere, and this is the homosphere. Now what by the name by the word you can understand homo. Homo means same, isn't it? So whatever the composition that we have studied, that is 79% of nitrogen by volume, 21% of oxygen. So this ratio or this composition is going to be accurate among this region: troposphere, stratosphere, mesosphere. Now after it crosses this mesosphere, it's begin with the thermosphere and exosphere. Now these are the basic layers, you are well aware of it. Now what kind of questions will come from this layer? Now they might ask you that among these different types of layer, which among this layer is the most closest to the earth's surface? Most nearest or the closest to the earth's surface? What is the right answer? Obviously it's going to be the troposphere. Fine. Very significant points. Now tell me some different layers where at which location we'll have the most coldest temperature ever. Coldest temperature ever. Coldest.
Ma'am, exosphere, ma'am. The
It's
coldest, ma'am, troposphere, ma'am. Troposphere, coldest, ma'am,
No.
troposphere, and
it is the mesosphere, the most coldest. Okay, it is goes around minus of 100 or something. Okay, close to 100. So this is the layer of mesosphere, the coldest. Fine. I hope you are noting
ma'am.
down the points.
Yes, ma'am. What about, ma'am, below, ma'am? Troposphere, ma'am. The layer is the troposphere in below, ma'am.
Below troposphere, troposphere begins with the surface of the earth to the at certain height. The height will range from 11 to sometimes 16 kilometer. There is some range. So it starts from 0. 0 is a sea level. Okay, suppose this is sea level or the surface of the earth. From the surface of the earth to the troposphere. Is it clear?
Yes, ma'am. This is clear, ma'am.
Right. And if they ask that which is the most coldest layer, so mesosphere is going to be the most coldest layer. So approximately near about minus 100 degrees Celsius is the temperature. Next, now which is among this is the most hottest, or is considered as the most highest temperature, like, so there is a name thermo. So from the word you can say, so this is a region where we have the gradually the temperature will start to rise. Okay, now after this what you have to know that there is some ranges that range from for troposphere, stratosphere, mesosphere, right? So yes, the significant point of the mesosphere, they can give that which of this layer where most of the fighter aircraft will be flying.
Yes, ma'am. My one more questions, ma'am.
Yes, please.
Ma'am, below the ma'am troposphere is the Earth's surface is your sense, ma'am. And what about ma'am thermospheres above ma'am exosphere and the exosphere is the ma'am in the above ma'am sun, ma'am. What about temperature, ma'am? Nearby sun, ma'am. Which have ma'am exosphere or thermosphere
uh,
nearby ma'am sun?
Near sun. Sun
Yeah,
is
ma'am.
it depends. Sun is too hot, right? So we are not going to consider that the near sun. We are not studying here the solar system. Keep that in mind. Here we are not
Yes,
studying the
ma'am.
solar system, right? So remember this things alone, right? And there can be some questions from the troposphere which I will tell you that. So there is something called as a boundary layer, or we can call as a atmospheric boundary of just a sec. Boundary layer. So if there is an option that atmospheric boundary layer and also you have a troposphere, then you must answer for this atmospheric boundary layer. So which is the most closest to the earth's surface or the sea level? If this kind of question comes, atmospheric boundary layer is going to be the answer. Right? Now there can be some possible questions. Now if they ask, if there is some air taxi, and the pilot has to fly, so which layer he or she, the pilot, will be which layer he will choose among this 5 option? If a pilot has to fly air taxi, which layer or which atmospheric layer will he choose?
Troposphere.
Very good. So the answer will be troposphere. So you should know what are the different types of aircraft and at what height they used to fly. So this kind of air taxi, especially air taxi or this kind, is to fly near about 6 kilometer. Okay, on an average 6 kilometer. Now if they ask about the fighter aircraft, okay, fighter aircraft, so what will be your answer then?
Stratosphere, ma'am.
It will be going to be the stratosphere. Okay,
Yes, ma'am.
is going to be the stratosphere. And if they ask like some kind of yes, along with this air taxi they can also ask helicopter. Okay, helicopter. They can ask this your passenger based aircraft.
Passenger aircraft will fly on troposphere or stratosphere?
It will be close, the height will be closing to this tropopause. So imaginary line which adjoins between this troposphere and the stratosphere. Okay, so basically if you see a heavy passenger aircraft or cargo aircraft, they will be flying about 10 kilometer to 13 kilometer. Okay, remember this range. If it is a heavy passenger or cargo aircraft, they used to fly approximately 10 kilometer to 13 kilometer. Okay, now there are some balloon satellites. Okay, balloon satellites. So where they will be flying? They will be also flying on this stratospheric region. Some balloon satellites are there. That is for weather prediction. Okay, so these are belongs to the stratospheric region. Now very importantly, defining what is Kármán line. What is the height of the Kármán line? So it is a 100 kilometer from the Earth's surface. Now it defines, once a flight crosses this Kármán line, it will define or begins with a space law, right? So we have many different laws, like we have Federal Aviation Regulations, we have ICOA, right? Some international standard atmosphere has been produced by ISO, ICAO, International Civil Aviation Organization, right? So there are many organizations, and each of them having some aircraft rules or space rule, right? So this space rule is going to be applicable once any flying vehicle crosses the Kármán line. That is the importance of this Kármán line.
Ma'am, what is the Kármán line, ma'am?
Just now I said Kármán line is one of the imagined line which is located at 100 kilometer. Now after any flying object crosses this Kármán line, that means crosses this 100 kilometer, which will have begins with a space law, initiate a space law, right?
Yes, ma'am, I understood, ma'am. But my one more question, ma'am. What about Kármán line below and above, ma'am? What the difference are between?
Below is, it will be of aircraft rule. Below it will be considered aircraft rule and aircraft law, and after this it will be a space law. That's
Yes,
a
ma'am.
difference.
Yes,
Fine.
ma'am.
Now another
law.
another type of questions that will come. Tropopause, what is a height? So you should know, approximately we used to estimate from 11 to 16 kilometer. Now for stratosphere we range from the 16 to 50 kilometer on an average. Then mesosphere we have 50 to 85 kilometer. Then here we have from 85 to 600 kilometer, and this is from 600 to more about 10,000. It's like above, right? So remember this measurements roughly around. Now there can be one kind of question, that why we have this range, like why it is not fixed, like it is up to 6 kilometer. If it has to be like, why we don't classify that? Why we always range like roughly around 11 to 50 or 50 to 85? Okay, we have some range, right? So why we have that range?
Because ma'am, this range, ma'am, swings, ma'am, to what the troposphere below, what the above, ma'am. Everything. So one is the point is given have, ma'am, about the atmospheric, ma'am. If troposphere is below, this is indicating, and above this is indicating above overall atmosphere and environmental about.
Okay, that's right, but that's not a reason behind it, that why we have the range. Now this range, I mean to say that here I say that I have said it is ranging from 0 to 11, or sometimes it can extend to 16, right? Here I've given that. Now why we have that extension? Because as we know, there is a earth, and when this earth is subdued under some radiation, that is from the solar system, now across the earth's surface, the heating is not equal everywhere. So the heating may be more in equator and can be less in the polar region, and due to this uneven heating, so what happens, the entire process, the atmospheric process, get slightly differ, and due to that region there is some, across the polar region to the equator, we have some variations of this troposphere. Okay, so that everywhere it is not same, that everywhere we cannot say the troposphere will lie on the 11 kilometer. So I can say that equator may be 16, polar region may be 7, and in the Tropic of Cancer may be 11 kilometer. So there is a variations based on the equatorial belt and the polar belt. The reason behind of uneven heating on the Earth's surface. The raw word is uneven heating.
Yes, ma'am.
So I hope I made you clear that what kind of questions that can come from here. Right? Okay. Now moving to important classifications. Now what kind of questions will come? So I don't have to explain much detail that what is lightweighter and what is heavier than weight and this thing. So you have to remember this nomenclature very well. Now what I will discuss here is that what type of question can come from this particular section. So basically we can expect two type of question. Okay, one is MCQ type, one is MSQ type. So first I will say what is the MSQ type question.
So
Now right, so they can ask you that choose or pick the odd one out among the options. Okay, pick the odd one
Ma'am,
out.
one doubt, ma'am.
Yes, please.
Whenever we go closest to heat, we will get more experience of heat, no? Temperature or something.
Okay.
Closest to hotter body, we will experience more temperature. That's no, ma'am. But when goes to the stratosphere, after the troposphere, why will the temperature will reduce, ma'am?
Why the?
The temperature will reduce, ma'am, in a stratosphere.
Because the properties are changing. So somewhere maybe isothermal region, somewhere there is a gradient region, right? I hope you know the difference of gradient and the isothermal, because iso means somewhere there will be some constant temperature, somewhere gradient means as we increase in altitude what is a variation of temperature. Okay, so that will come in the later part also, that why there is a variations mathematically we will see that.
Okay.
Okay, that also we will come.
Okay.
Alright. So first we'll see odd one out. Now they can give you that certain options, like they can give you the option like one option kite, one option balloon, one option airships, and another option they can give ornithopter. I request others to please kindly mute yourself. When I ask you question, you can unmute. Alright? Now first and foremost, this is an odd one out question. Now they have given you the options like kite, balloon, airship, and the fourth one they have given ornithopter. Now which among this is going to be the odd one out? What you can see, kite, balloon, airships belongs to the lighter than air. And what is the ornithopter? It falls under the heavier than air. So among these four options, so ornithopter comes under the heavier than air. So this is going to be the right option. Is it clear? Did I make you clear?
Yes, ma'am.
Yes, ma'am.
Yes.
Right. So another type of questions can similar kind. So they might give you pick the odd one out. So among this odd one out, they can give you the example like airplane, they can give seaplane, they can give hover, instead of this amphibian they can give hovercraft, that is a C option, and the other one they have given as helicopter. Now which among this is going to be the right option?
Airplane.
Huh?
Airplane.
Why airplane?
Because, ma'am, this is a part of ma'am, seaplane, helicopter or hovercraft is a part of aeroplane.
Right. Very good.
Yeah.
So you should
Yes, ma'am.
be alert with this nomenclature. So here the right option is going to be the airplane. Okay. So these are the classifications. Under sub classification only we have this part.
Ma'am, actually we can say helicopter also, na? Because it is normal airplane and this is rotary wing.
No. This is hovercraft also having the rotor. This is also having the rotor, isn't it? Like it is like having lot many principles for the hovercraft. So isn't it? I'm just giving you to understand the system, how actually it works. Fine. I hope I made you clear. So this is one of the type that can possibly ask. Second is that MSQ type, that is multiple selection. So they will give you maybe the next option I will give, which among this falls under engine driven aircraft. Okay, engine driven aircraft. So among this engine driven, they will give you there's rotary wing. They can give you separately as sailplane. They will give you the C option, gyroplane. Another one is a airplane. Okay.
Glider and sailplane, ma'am.
So glider. So the right option is going to be the sailplane or the glider. Right. So there are some power gliders, so I have not selected that. Sailplane is completely known for the unpowered aircraft. Right. So you have to be ensure that what they are asking, read the question correctly. And they might also ask that pick the odd one out, pick the correct one. Okay. So this kind of questions they frequently ask. So you should know with this nomenclature. Now, here also I don't have to say much about it. So as you are already going to be aerospace engineer, aeronautical engineer, you know what are the different unique units we have, what are the different unique features of wing, unique features of tailplane, fuselage, and we have for the intake, that is different kind of engines. Right. Now this is a very basic things, and they ask a lot much of question from here. Now again from here there is a chances of asking pick the odd one out. So you should know what are the things that are located on a wing, what are the things are located on the tailplane. Okay. Now these things you are well aware of it. Now the most important part is the type of configuration. Now what do I mean by configuration? Okay, this is very important. Now first of all, location. Now whether I want to keep my wing high wing or low wing or mid wing. Okay, three options: high wing, low wing or mid wing. So can you tell me each example or applications of high wing? So where you mostly or frequently see high wing aircraft?
Military aircraft.
Okay, military cargo you can say, right?
Yes.
Or any
Military
kind
cargo
of
aircraft.
cargo aircraft. So this is very important, cargo aircraft.
Ma'am, fighter also, ma'am. Fighter aircraft.
But most of the fighter aircraft, if you see that if it is a for dogfight, mostly they are not a highly high wing configuration. They are mid wing configuration fighter. If I generalize it, except few, the most generalized way I'm asking fighter. When we talk about fighter or when we talk about supersonic any kind of dogfighter aircraft, not for the surveillance, not for the transportation, right? Not for any kind of military use. Only for the fighter purpose, fighting purpose, right?
Yes,
So
ma'am.
they are for a mid-wing aircraft, or mid-wing configuration. Remember this, as I have said, they used to ask you the application. Now, high wing, when we talk about one more configuration, you can say seaplane. You can say about seaplane as well, right? Seaplane also you can see they are mostly high wing configuration. Now what is the most low wing configuration? Anyone?
Passenger aircraft.
Yes, it can be.
Passengers, ma'am.
Yes, it can be a business jet, it can be any kind of passenger jet. Mostly, again, it varies. Again, because there are different types of designs, configurations. So these things you have to remember, that locations and the position. Okay. Next we have, one is a location is over. Second we have the platform. Now what do you understand by the platform? What are the different types of platform? That means how this wing look like. So there are the n numbers of platform. So basically we have some rectangular we have. Then we have our delta wing. Now delta having lot many different types: compound delta wing, crop delta wing, simple delta wing, ogive, right? Ogive types are also there. Then we have swept wing. Now swept can be backward, swept can be forward. Then we have tapered wing, elliptical wing, right? Now here first we'll not go much in depth, we'll only discuss about the applications here based on the platform. What type of applications? So where you can see the rectangular wing. Give me few of the examples of rectangular wing.
Rectangular wings, ma'am. Ma'am, flaps, ma'am, winglets, ma'am, spoiler, ma'am.
No. I'm asking for which type of aircraft. I'm not asking.
Ma'am, commercial, ma'am.
Okay, so answer should not be like commercial. The answer should be like any kind of small aircraft. So the small aircraft, they mostly prefer to use rectangular based wing. For an example, let's take an example of a very small aircraft like a Cessna aircraft. Okay, so Cessna aircraft, if you see that they have this rectangular wing configuration. Fine. Now when I talk about delta wing, so which aircraft will you suggest? Delta wing.
Most of fighter aircraft.
Most of the is a fighter aircraft, and whose speed is obviously has to be Mach number greater than 1.
One
Okay.
supersonic.
Supersonic, right? Now when we talk here about this rectangular, so there also we can decide it by means of Mach number as well. So what will be the Mach number in an approximate?
Subsonic.
Subsonic
Subsonic below the 1.
below
0.2
0.3.
to
Yes, 0.2 to 0.3, less than 0.3. If the Mach number
Yes,
is less than 0.3, then we'll use your rectangular wing. Now where we'll use the swept back or swept forward? Where we'll use swept back and where we'll use swept forward?
Transonic.
Very good. So when we'll use some transonic, the swept back starts with 0.6 to 0.9. It ranges within that, or sometimes close to 1 even. So if the aircraft speed is within this range, so it is recommendable for the as a swept wing. Then taper.
taper is, ma'am.
Okay. Talking about swept wing, mostly we use for the passenger. Okay, passenger. Now tell me for the this taper wing.
Taper is, ma'am.
Hmm.
Like, ma'am, business, ma'am.
There again, taper may vary with the small aircraft, and sometimes you can also find this taper based wing some military aircraft. We are not categorized with the fighter, but some kind of military aircraft you can find as a taper wing. Fine, military aircraft. Now what about this elliptical wing?
Electrical, ma'am. Passenger, ma'am.
Not passenger. Here also there are some fighter aircraft, so you can use on transonic speed, you can use this elliptical wing. There are some trainer aircraft. Okay, trainer aircrafts are there, so there also you can use elliptical wing. Okay, fine. So I have made it clear that with a different plane configuration and the location. Right, now next I will discuss about the winglets. Now why we use winglets in the aircraft? Winglets. Anyone?
Ma'am, to avoid vortices on the wing roots.
Yes,
Wing
to
tips.
avoid the tip vortices. Okay, so if we use winglets, so we can cut down the vortices, so our which drag will come down. There are different types of drag. Which drag will
Induced
come
drag.
down? Induced drag will come down. Okay. Now spoiler, you are well aware where it is located and when it is used. When the spoilers are used. When the spoilers are
To
used.
create drag.
Spoiler
So
is on air, on the wing of the on the top of the wing of the aircraft, and it is used for like braking.
it is like
Drag.
it is
Create
used
drags,
to
ma'am.
create drag. So it will be located
Yeah,
over
ma'am.
the wing, over here, over the surface of the wing. So this is only used very precisely during landing. It is used during landing. And why? To additionally reduce the inertia force. Okay, reduce the inertia force. Though the pilot will be using the braking system, that is not it is not sufficient to reduce the inertia force. To reduce the inertia force, we are using spoiler to deflect upwards. So using that, we are creating increasing drag, lowering lift and lowering the thrust. These are the core parameters we are using the spoiler. By the name itself, you can understand that what we are spoiling. We are spoiling the lift, which is a major factor. The second major factor is the thrust. So both the things we are reducing it. Now, sorry, there is a by mistake I have written here. It will be aileron. Okay, aileron. Okay. So which surface, control surface, is in our aircraft? Wing. Which control surface is our aircraft wing?
Ma'am, ailerons.
Ailerons are there. So in the vertical stabilizer, what is the control we have? Which control surface?
Rudder.
Rudder we have. And in the horizontal surface?
Elevators.
Elevators are there. Now very importantly, there are many questions they ask from the control surface, control movements. So I will come just after that. We complete this part. Now this wing configuration I have discussed, right? Now very importantly, now we'll go for the empennage type, empennage configurations. So what are the different types of empennage configurations are there? What is the name of this configuration?
First one like T type, T tail type,
Okay. Now
T-tail type and T-type.
canard.
see, first you tell me what is this configuration? Name of this configuration?
Empennage, na?
Yes. Empennage or tailplane? Anything?
Tailplane.
Or tailplane, both.
So what type of configuration? What is the name of this configuration?
Ma'am, T-type and B-type, ma'am.
This is a conventional type. Okay. This is known as a conventional tailplane. Remember, conventional, that means a traditional, old fashioned. So this is a general way of keeping it. So that's why it named as a conventional one. Clear? Now second one. Now here we have this horizontal plate, right? Horizontal tail. Now stabilizer, sorry. Now if the stabilizer, if I fixed over here, if I fix it over here, what is this configuration name?
Ma'am, it's T-type tail.
T-tail.
It is called as a very good T-plane. Okay, they don't say T-type, T-tail plane. Okay, T-tail plane. Next, some aircraft you will notice that it is not at the top, but in fact it is somewhere in between. Somewhere in between. Okay, not at the tip. What is that configuration called as? What is that configuration called as?
Aileron, ma'am.
Huh? What is that configuration called as? So it called as a cruciform. Okay, remember this term.
What? Cruciform?
Yes, cruciform. So if it is in between this the vertical stabilizer, it is called as a cruciform. Okay, now some more few different types we will see. Now you mostly have seen this type of, in place of this, instead of this one, okay, we will have only in here like this and one like this. Okay, so what is this configuration called as? Here there will be nothing, only both the side will have. So this kind, it looks like H, so it is known as a H tail plane.
Hello, ma'am. My one more question. How to, ma'am, remember everything, ma'am? I one by one, some few only. I remember, ma'am, how everything's, ma'am. Confused, ma'am. How to
Don't
remember
worry.
this is very problem.
Don't worry, these are the just a practice. So when you will perform this mock test, so you will study, right? So when you keep on studying these things will fix on your mind. Because why we are discussing these things? Because in upcoming some more topics we will discuss on few important things, right? So that's why I thought like first we'll give some layouts of this, then we'll enter into the core part.
भाई प्रमोट तो हो रहे हैं यार, YouTube वगैरह पे वीडियो देख ले, हर जगह तो यही बोल रहे हैं।
Yeah, sorry.
प्रमोट के हाँ पैसे तो ले रहे हैं, मतलब तुम्हें एग्जामिनेशन फॉर्म तो भरना पड़ेगा ना एटलीस्ट।
Sorry, I didn't get your point. Who's that?
He's speaking, ma'am, about other things, ma'am. Please inform, ma'am. He's not speak, ma'am.
He's
Other
speaking
related,
to
ma'am.
us. I'm not getting your point. Like whoever it is.
I think, ma'am, is speaking to these persons about YouTube and application form.
Application. Okay. What? I'm not able to get it. What he's.
I think he's speaking to someone else and he just didn't mute himself.
All right. Okay.
Yes, ma'am. This is correct, ma'am.
Okay. Fine. Right. Then very important point is twin tail. Twin tail means, so just like a stealth aircraft, so here we'll have one radar and here also we'll have another radar. Okay, two radars will be there, right? So this is the twin they call as a twin tail, not radar, twin tail. So these are the 5 important. There are many different types as well, but these are the another one I would like to discuss as a V tail. Okay, it looks like a V shape. It looks like a V shape. So that is a V tail.
Ma'am, in V-tail the rudder is not present, na?
V tail?
Like in V-tail the function of elevators and rudders are same. Like in V-tail rudders are not present. Like the vertical stabilizer and horizontal stabilizer are both same in V-tail.
খোলাই আছে, আমি তো বন্ধই করিনি। Yes,
I
am I
can't
audible?
getting any point.
Yes, ma'am, you are audible.
Okay, I didn't get your point, dear. Can you repeat?
Actually, ma'am, I want to say that in VTail there is no vertical stabilizer.
Okay, right. There it is a combination of both. Okay, there is
Both,
horizontal
yeah.
stabilizer and the vertical stabilizer. So how they
Yeah.
use the control surface like a rudder, the like elevator and ailerons. So on
I'm
this
like
kind of cases, they combine the control surface like flap mounts.
like in this rudder waiters.
Yes, exactly. Okay, now very importantly remember the few applications. Now when we talk about the conventional, so if there are some applications, so what will be your answer? So this is going to be the passenger aircraft. Just remember example of Airbus 380. So Airbus 380 they have the conventional one. Then T plane. So T plane, this type of configuration are widely used for business jet. Okay, again similar kind of type is a cruciform is also widely used in a business jet. Kindly please mute, I request to mute yourself. uh, from where I'm getting. Okay, now it's better. So coming to that, this cruciform and T-tail is used in business jet. H-tail plane, these are used in very small aircraft. Okay, H-plane, they are used in a very small aircraft. Then twin tail is used in a fighter aircraft. V-tail is specifically used in UAVs. Okay, so remember this basic applications. Okay, so this basic application might help you in the future. Now switching to very important part of this, the flight movements. Okay, so flight movements. So you know what are the basic flight are there. Now here
Yes.
you can see that two things it's written, port wing and starboard wing. Can you see here? So basically in your future exams also they will they will not say right or left wing. They will always give the questions with the port wing and the starboard wing. So I hope you are well aware what is a port wing and starboard wing. Are you aware of that?
Yes, ma'am.
Right, very good. So
Left one is the starboard. Right,
So
the
this
right
is
one
the
is the starboard.
so this is the port wing. See, remember
Yeah.
in this way, the side you are boarding into the flight. So that is a port wing. The other side is going to be the starboard wing. Clear?
Yes,
Now here
ma'am.
we have three different sections and we are going to discuss one of the principle one by one. So first I will start with the aileron. Now aileron, what it does, where it is located. First it is located on the wing section, right? So it is, let's assume it is located one here and one is here. Now why I have drawn in a different way? One, it looks like deflected downwards, one it is deflected upwards. So what is the mechanism? It's a differential mechanism. So what is mean by differential mechanism? If one of the component is deflected downwards, the other one will be deflected upward. So if I observe in the front view, so this is a front view of your aircraft. So this is the port side and this is a starboard side. Now this thing you have to understand it very carefully. So from this particular point they used to ask you the conceptual question. Now what happens here, as I have said, as it is a differential, if one is deflected upwards, so port side is deflected upwards and starboard side deflected downwards. Fine. Now using this aileron, now what happens? It performs a rolling motion, right? Now how I can say the aircraft is rolling? Either from the front view it will rotate in a clockwise direction or in an anti-clockwise direction, or I can say counterclockwise or clockwise. Okay, C means clockwise, CC means counterclockwise. Now before giving a detailed explanation, you tell me in this particular phenomena which rotation it will perform. It's going to perform in a clockwise or it is going to perform anti-clockwise.
Ma'am, both is going, ma'am, anti-clockwise, ma'am, both, ma'am.
No, in this particular situation, now if the port wing is deflected upwards and starboard is deflected downwards, in this particular scenario, which side it will rotate?
Anti-clockwise, ma'am.
No. How? Can you explain this?
Because, ma'am, is the rotor is to above, ma'am. Above is same as like, ma'am, ceiling fan, ma'am. Ceiling fan is, ma'am, rotating, ma'am, anti-clockwise, ma'am.
No.
And table fan is rotating, ma'am.
No,
Ma'am, the port wing goes up, na?
Huh.
And the starboard wing goes down.
Yes.
So, ma'am, it's anti-clockwise, na?
Anti-clockwise.
Yeah.
Yes, ma'am. Because,
If
ma'am,
port wing goes up, like clockwise is like if starboard goes wing up, then it will go to clockwise.
Okay.
But
how many of you agree with the same thing? How many of you?
ma'am,
Okay, fine.
ma'am, because
Ma'am, it is based on the point of view, ma'am. They are where they are standing in the front or back.
I'm talking from
The
the
standing
front
in the
view.
back is the clockwise, ma'am. It's standing at the front wise, it is anti-clockwise, ma'am.
Actually, in port side, that angle of attack will be more.
Port side angle of attack is going to be more.
and it is anti-clockwise because the port side is going up because it has more lift.
So, no. See.
Ma'am, it is clockwise, ma'am, because we are standing in the port and seeing as the aircraft movement from these sides, our side.
See, I am telling you the perspective, what you are telling should be from the front view. If you are the observer and you are seeing from here, from the front view. Alright?
ma'am, if your observer is, ma'am, if source and observer, ma'am, then vice versa, ma'am. If source is showing anti-clockwise, observer is see, ma'am, clockwise, ma'am.
Clockwise.
Yes, ma'am. If ma'am, source is going on, ma'am, anti-clockwise, then observer is see, ma'am, clockwise.
Okay, fine. Whatever. Now.
Vice versa, ma'am.
See.
Vice versa, ma'am.
Okay, fine. Now here I will clear whatever you have said. Now you justify your answer from what I explained, and
Yes,
try to remember that principle and how actually the lift occurs, because that if you understand this aileron process, then you will understand for how this elevator and the your radar works. Fine. Now first try to understand this. Now first, what is the point I have said? Aileron is a differential motion. That means if the starboard deflect downwards, the port will deflect upwards. Fine. Now just imagine this is how the free stream air is coming. Okay. And it is flowing over the aircraft. Right. Now whatever the observation I am going to make, from the front view perspective. Again and again I am telling you, I am going to give all the perspective from the front view. Now this is how the air is coming and going to flow over the aircraft. Fine. Now as this object, or I can say this control surface, deflected downwards, so when these airs are streaming over this particular surface, what will happen? It created an obstruction. So all this air molecules is going to hit over here. Do you agree with this point? So as it created obstruction with the flow, moving flow, so all the air is going to hit over this control surface, this particular panel. Yes or no?
Ma'am, you are talking about the ailerons or you are
Yes,
talking about the wings?
Ailerons, this particular control surface, aileron.
Ma'am, so I want to tell you, I want to ask you one thing. Like, if the ailerons is like if the port aileron is going up,
First you tell me,
then
no, forget about port and the starboard. Here we are
okay,
making this process, like port is up
yeah,
already. Already the port side is upward. I have not come to this second half, port side. I am just focusing on the starboard only.
ma'am. Basically, I want to ask you the port side aileron or the port side full wing.
I am mostly asking about the control surface. Aileron.
Okay, okay.
Okay. Starboard side aileron only I am asking. So this is deflected downward. So downward all this kind of air is going to hit. Now look into the port side. Port side, the aileron is deflected upwards. So what will happen? The air molecules are going to come here and hit over the surface. Agree?
Yes,
Now
ma'am.
as it is creating an obstruction. So just like you are going in a bus and all of a sudden you keep your hand outside the window. So what do you feel? You feel like winds are hitting on your hand and try to lift you like backward, keep your hands little more backward, right? So same kind of feeling will have or experienced by this aileron. So these ailerons are fixed, okay? Just imagine it has been deflected as 20 degree both the side. It has been deflected 20 degree both the side and is fixed. So at this 20 degree, so all this air pressure is going to fall over here. Now due to this obstruction, this is created an obstruction, one in the lower part, one is the upper side. That is upper side comes in the port side, lower side is the starboard side. So due to this obstruction, what will happen? It creates a high pressure zone, and in the port side, upward side, it creates a high pressure zone. So one side, the lower part creates a high pressure, and other side, that is a port side, upward portion, we have the high pressure. Now what is the nature of flow? Always from high pressure it will transform to the low pressure to maintain the equilibrium, to maintain the balance.
Yes, ma'am. Then
Fine.
ma'am, stagnation is constant, ma'am.
See, don't go for the stagnation pressure. I am only talking about this basic static pressure. Stagnation, don't go in more complicated way, right? So what is each and every point, what will be the pressure, don't go, right? So first try to understand the phenomena first, right? So here bottom we have the high pressure. So as we have no obstruction, so obviously because of the nature it will become a low pressure. Now what will happen here in the port side? Upward we have the high pressure and bottom we have the low pressure. So due to this difference in pressure, obviously from high pressure to low pressure it will generate upward lift, right? Some upward, let's forget lift, let's remember some kind of force. Some kind of force will generate on this direction, and on the port side, as upward direction we have a high pressure, lower we have a low pressure. So it will, the force act will towards downward direction. Follow? So in the starboard the force is acting on the upward, and in the port side it is acting downward, right? Now both the wings are having a different kind of force generation. One is lifting upward. So just imagine this is an aircraft is fixed and it is moving, and this wings are trying to move upward and one wing try to move downward. Now gradually it is moving and this is going up. So which side it is rotating? Which side it is rotating? So in this particular phenomena, from your front view perspective, the aircraft are going to make a clockwise rolling motion.
How to, ma'am? Clockwise, ma'am.
Why?
But ma'am, if ma'am this is plane is going on, ma'am, a plane is ma'am rotating, ma'am, clockwise, ma'am, observer is ma'am see, ma'am, anti-clockwise, ma'am. It's vice versa, ma'am, because front of how to, ma'am, airplane is this person is rotating, ma'am. This clockwise, there is observer.
Can you please explain me how, where is the observer? First of all, which portion you are taking the observer? Where the observer is? In the front of the aircraft or the back side of the aircraft? Where is the observer?
It's ma'am front of, if ma'am front, then see, ma'am, if ma'am similar, ma'am. It's ma'am front, in the front, ma'am.
I'm unable to get your question. If you are okay with it, you can speak out with Hindi if you're comfortable.
I speak both, ma'am, language, ma'am. I speak, ma'am, if front of view, ma'am. If you see, ma'am, then after that, vice versa, ma'am. If you see behind, then after that, clockwise.
No. Yes. But why you have to see behind? You don't have to go behind. Observe only from front. See, the question they will ask you from the perspective, front view. Okay. So don't think in the backward side. Backward side you are talking that it will be anti-clockwise. Then if they ask from the back side, then if you say anti-clockwise, then you are right. Okay. But here I am talking about the front perspective, from the front observation. Okay, or from the front view. So then your answer is a clockwise. So if they ask a question like from the rear view, okay, they will not say behind, they will say, use the call as a rear view. Rear view means a backside view. From the back end you are observing that what is the motion. So then it is going to be your anti-clockwise or counterclockwise.
Yes, ma'am, understood, ma'am. But anybody see, ma'am, airplane is going on, then after then, ma'am, we see airplane is go moving, ma'am, then after then every person is see, ma'am, behind and backward through.
No, you don't have to see in that perspective. No, never assume. Okay, this is one of the very important thing to understand when you're going for an competitive exam. Never estimate anything. Okay, understand that what they have asked in the question. In case they have not given any perspective, either you take side view, top view, okay, or you take front view. These are the basic phenomena you have to take. Never estimate anything by yourself. But most of the cases they will be giving you the perspective of a viewer. Okay, so never understand that if the aircraft is flying, so I will see from the rear part. No, please do understand these things. I hope I made you clear this phenomena.
Yes, ma'am.
Right.
Yes, ma'am.
Right.
Yeah, ma'am, got it.
Now, similar kind of phenomena is going to occur in both the elevator. So, when we talk about elevator, so what is the purpose of elevator? For the pitch up and pitch down. So, which observation is going to give a very fruitful result? So, if we see from the side view, so this is called as nose up, that means pitch up, and nose down is going to call as a pitch down. Fine. Now here we have the elevator which is fixed. So either this elevator can deflect downward or deflect upward. Fine. So both the ways it is possible, and here there is nothing differential. That means if this is an elevator from the front view, I am again observing from the front view. So both, if one elevator is deflecting downwards, fine, so both will be deflecting. If both are deflecting upwards, that means both will be likewise. So there is no case with a differential form. Fine, this is clear. So elevator, if it deflects downwards, so you tell me what is going to happen with this motion, whether it's going to make pitch up or pitch down.
Pitch down, ma'am.
Pitch down. All of you agree with this?
Yes, ma'am.
All of you. Very good. Why? Because the same thing occurs. The airflow comes and heat over the surface. So as it is creating again an obstruction, so there is a development of high pressure zone, and on the other side it becomes a low pressure zone. So there is an upward lift. So as the aircraft is moving forward at certain stabilized way, so this tailplane will go upwards, right? The entire body, the upward side or the rear part of the body will go in the upward because of the because of the lift. So if it goes up, then obviously the nose will come down. So as a result, we will have the pitch down. Clear? Now this will act in a reverse way. So if the elevator is deflected upwards, then it will have the pitch up phenomena. Okay, or sometimes they call as a nose up. So they ask you this kind of questions in GATE as well. So you should have the clear understanding how actually the elevator works, how actually your aileron works. Now similarly, the same thing is going to happen for the rudder. So rudder, what is the motion of a rudder? Makes an yawing motion. So if I observe from the top view, it's an yawing motion.
Yes, ma'am.
It can either go towards the port side or go to the starboard side. Okay. Now there are a lot many textbooks that where they have referred left and right, but here again comes left and right will differ with the perspective. So we will fix with the port side and the starboard side. Okay, even in your GATE question paper you will find majority of the question will be either from the port side or the starboard side. Okay, now when here we have the rudder. Okay, this is the one. Okay, now either it can go on this way or this way. Roughly I am sketching. So if it is deflected towards the port side, so all the air is coming and going to hit over here. So here there is a development of high pressure, the other side is going to be the low pressure. So the force is going to generate in this way. So this tail section will try to pull this side and the nose section will try to pull on the other side. So as a result, if the rudder is deflected towards port, okay, port side, then the nose will also move towards the port. Now it is going to be the vice versa. If the if you are using the rudder towards the deflecting towards the starboard side, the nose of your aircraft will also move to the yaw towards the starboard side as well, with the same phenomena. So this phenomena you have to ensure that wherever it is deflecting, so that particular portion it will create a high pressure. So high pressure to low pressure, the lift will generate. So if this is lifting upwards, so what will happen to the nose? Now there is another question has asked in I think 2014. Like the question was very simple. So as the air is flowing over the aircraft and all of a sudden due to heavy gas, the pilot tends to deflect the control surface. They have used that elevator has been deflected downwards. Now in that case, what kind of lift will produce? Nose lift, tail lift, or they have given a few more options, a wing lift, like that. So here
And
the
nose
answer is,
lift.
see, I said it is deflected downwards.
Yeah, okay.
Deflected downwards. then your
So it's
tail
tail lift.
tail lift will occur
Tail lift.
and nose will go downwards. So how the motion of the entire body, you have to understand it clearly, right? Did I made you clear? Now
Yes.
there are few more questions you have to certainly know about the fuselage body. So as you can see here, I've shown some three images. Okay, three images. So you can distinct the fuselage body, or you can say fuselage configuration. So for the glider, how it looks like, it's look like a kind of tube-like structure. For a big passenger aircraft, you can see it looks like a cylinder type. Okay, and for the fighter, you can see how it looks like, and where is the engine location, you can understand where is the engine location, which type of wing, then which type of landing gear they used, see the difference in their tailplane. Okay, tailplane, the location of the wing. See, glider also you can see here a very different type. One more type is there, polyhedral type. I forgot to mention it early. Polyhedral type wing. This is a polyhedral type wing. Okay, high wing with a polyhedral. That means each, if I cut down this wing at certain extent, it increases gradually. So if I observe from the front view, it's something like this. At each and every interval, it has some inclination. Okay, right? I hope whatever we have discussed today, it is understood.
Yes, ma'am.
Yes,
Right.
ma'am.
Yes, ma'am.
But
Okay.
this polyhedral wing, what is the benefit for this polyhedral wing? Or
Yes, that's very good question. See, as you know that glider, so what is the main purpose of the glider? To endure for the longer time. Now, two things, as you have asked, what is the purpose? So to understand this particular thing, two things you have to know: the range and endurance. Now, as a definition, what is range? Range is what is a maximum distance traveled by an aircraft with one loaded of fuel. Okay, loaded of fuel. That means in a tank, completely fuel is filled, and with that filled tank, how much distance that aircraft can travel? Distance. So that is meant by range. Endurance means with the total
how
loaded
much
of fuel, how much time it can travel. And this, especially this glider or sailplane, whatever you call, their main purpose is to endure for longer period of time. That means how long time they can sustain in the air. So for that, what is their require is they need to the speed is not a very important criteria. The important criteria is how much long wingspan and how much they can float in the air. So this polyhedral type fulfill all this type of benefits. It can helps to increase the endurance. It helps to produce a huge amount of L by D, that is a lift to drag ratio. It can go, I think, 30 to 25 to 35, 30, nearly about that. That much amount of lift it can generate. Lift to drag ratio it can generate. Okay, so that's a benefit of polyhedral. And as I said, speed is not a important consideration over here. So they just need to glide. Any other question? Anyone having any other question?
No, ma'am.
Right. Okay.
I have one doubt.
Yes, please.
Fuselage shapes, if you see it is changing. Fuselage shapes, how they are like designing now.
See, first of all, why there is a difference in this fuselage. There are few things that you have to understand here. Fuselage is a main thing which helps to increase the weight.
Okay.
Okay, so we have to decrease the weight of the aircraft. Now, as in the glider, we have just only one passengers or maybe two sometimes. Depends on what type of glider it is. So we don't need to create a very bulky at the rear part. So it will unwantedly increase the weight. So we have to cut down, and the same time maintaining the aerodynamic profile. Right, so that's why to understanding these two factors, one is a weight, another is a aerodynamic profile. So that's why there are different types of, and here you see in the passenger aircraft, obviously you have to accommodate the passenger over here. Okay,
Yeah.
so you cannot make it as a very this kind of streamline structure. So if I have to make streamline structure, this portion will get bulky. So again, you don't want a bulky structure. Right. So these are the things, and if you say how this aerodynamic profile creates an benefits, or how it creates an pros and cons. So there are a lot many things. Is a drag, parasite drag. The first and foremost, I will say the parasite drag. So based on the length of the fuselage, we can decide what will be the parasite drag, or mathematically we can express that CD naught parameter. Okay, so that's why we have to constrain this different types of fuselage for different type of aircraft.
And then one more doubt is, while we are designing for wing, we will find a Reynolds number now. But for fuselage, that same Reynolds number will not be there, but it will be a higher value, because while designing wing, we will be taking chord length, but while designing fuselage, we will be taking the entire length of the fuselage.
Yes,
So how that?
see, very simple. You were asking that why it happens so, right? So what is the basic formula for Reynolds number? Rho V L by mu. It is a formula. Now here, when we are using for a wing, we are using the for the chord length, right?
Chord length, yes.
And when we are using for the fuselage, we are using the length of the fuselage. So obviously this is a directly proportional. So if this goes high with the same fluid flow, so obviously the Reynolds number of a fuselage is going to be higher.
No, ma'am, I'm asking like the difference between that Reynolds number of fuselage and the wing is very high. Actually, difference considerable. The difference will be very high.
Yes.
So does this affect
yes,
does this,
absolutely. That's
how-
why, yes, the first and foremost is the interference drag.
yeah. Yes.
This is the interference drag, because here we have some another like viscosity, I can say, a different density parameter of the flow, you can say, and over the wing we have a different, and that's why the concept developed with a blended wing body. So where there is no interaction with the body and the fuselage and the wing, and we can cut down this interference drag.
Generally, high Reynolds number is good, or Reynolds number is good.
See, whether high Reynolds number is good, low, it will only we can identify based on which speed, what type of aircraft, right, and other features. There are a lot many things that it depends on. We cannot judge only by a single parameter. Okay, but definitely the Reynolds number is quite a dependent factor to give the what is the amount of drag produced by that particular body. That is for sure. Okay, so this is very difficult to say without any computation that whether it's going to be beneficial or not.
Yes, thank you.
Yeah. Okay, now before winding up this today's session, let me give you some of the important things. Yesterday I have made a video on this how to register. I hope all of you have gone through, and in that video I have shared some vital important highlights, that how you're going to prepare, what are the things you should remember. So, and before filling up the form, what are the important documents that you should keep handy with you. So please follow that and complete your registration process as soon as possible, and after completion kindly share your this enrollment ID, application number. I think you will be getting not enrollment ID, application number. Send me your application number once you're done your registration process. Fine. And if you're facing any difficulty in your registration process, please let me know. With
Ma'am, ma'am, anybody form application form fill ma'am without hesitate ma'am. After then ma'am, window is open ma'am within the 1 month. If anything is wrong, anybody fill wrong, the email inside is already come ma'am. If anybody.